Hello everyone! In the previous part of this Metasploit shellcode analysis tutorial, we've seen that when executing from the debugger, the code that runs from the dynamically allocated memory generates an exception and doesn't execute correctly. Let's reproduce that. So we start the execution. We have a call to function 1, which will skip, and this is the point where we execute the code dynamically. Let's add a comment. All right. And here we've seen that there are some functions. Let's see which function generates the exception. This is Internet Open. Next we have Internet Connect. Things start to make sense. Then we have Open Request. Looks like this shellcode is doing some HTTP requests. And then Internet Set Option. And this is in HTTP Send Request, which triggers this unknown exception with code 6A6. In order to understand this, we have a few possibilities. First, we can check the MSDN documentation, and we can see the error code 6A6 and possibly understand what it means. The second option is to try a different debugger. For variety, let's do this. Let's use the X96DBG debugger, the 32-bit version, and see what information is different from IDA. I'll load a copy of this file that we're analyzing in IDA, and simply run it. That's the first stop at the entry point, and again we run into the same exception. If you look here, the code is 6A6 and the exception name is RPC-S invalid binding. We could do a bit of online research and see what it means, but that might not prove that much useful. What we can do instead is pass this exception to the application and let the application deal with it. Let's first restart FakeNet to make sure that the shellcode is working correctly, because if it does, we should see an HTTP request. So we press run to pass the exception up to the application. It triggers a few more times, but notice we already see some DNS requests here. And if we pass it a couple more times and look in FakeNet, there is the request made by the shellcode for the GS resource. We should be able to do the same in IDA Pro, even without understanding what the specific exception means. Let's see. I will start FakeNet again. Then restart debugging. quickly run into the same exception. If we want to pass it to the application, we can press F8 and then we can select Yes, pass to the application. Again, pass it to the application. Again, pass it to the application. To do this all the time, for this particular exception, we can change the definition. Let's add a name, RPCS invalid handle. Code 686, and then we want to pass it to the application without suspending the program. And as expected, we see again the correct HTTP request. Let's run the debugging session again. This time we shouldn't be asked to manually pass the exception to application, it should be automatic. Perfect. The application handles the exception and works as expected. Let's try with FakeNet running and see that we have the request. As expected, here is a request and we have no exception in IDA. To change this behavior back and to see this exception again and pass it manually to the application, we can go to Debugger, Options, Edit Exceptions. And at the end of the list, there's the one we've added manually, RPCS invalid handle. Simply delete it from here, and the next time we try to debug, we should be prompted what to do about it. Alright. So, to recap, in this quick video, we've seen how IDA Pro deals with exceptions. We've seen how to identify exceptions based on their error code in both IDA Pro and X96DBG, and also how to change the way IDA Pro reacts to exceptions. Also how to choose between suspending the program or pass them directly to the application to deal with them. Thank you very much for your time and see you in the next video.